Oh no, we're back. That's right. And I know everyone's asking the burning question, how do I solve and graph negative 4x plus 6 is greater than 42? And it's kind of the question of our time, but we're going to take care of that right here, right now. So here's my variable, and I always ask the question, what's happening to the variable? Well, I'm multiplying it by negative 4, and then I'm adding 6 to whatever that is. So negative 4 plus 6 is greater than 42. So looks like there's two things happening. I'm multiplying, right? That's multiplying. And I'm also adding. So those are the two things I have to undo. I have to undo multiplying and the adding. I'm going to undo this first. So I'm going to undo the adding first. So how do I undo adding 6? Well, I subtract 6. If I subtract 6 from this side, I have to subtract 6 from this side. And I can do that. When I do that, these two will cancel each other out. They're opposites. So on the left side, I have this negative 4x. On the right side, I have 36. And I bring down my inequality. So now I have negative 4 times x. Well, how do I undo multiplication? I divide. And I'm going to show the division by way of a fraction. So if I multiply by negative 4, I need to divide by negative 4. Both sides. Oh, hey, boop, boop. Alert, alert, stars. Star this point. Remember, when you multiply or divide an inequality by a negative, you get flipped. That's right. When I multiply or divide by a negative, negative 4 divided by negative 4 is 1. And 36 divided by negative 4 is negative 9. And the inequality gets flipped. So my solution here is going to be x is less than negative 9. Let's graph this and see if it makes sense. So what I'm saying is that all my answers begin at negative 9. So 0 is over here, and then 1, 2, 3, 4, 5. I'll put negative 5 here, 6, 7, 8, 9. So here's negative 9. So this is saying that x can't be negative 9 because it's not equal to it, but it'd be anything less. So I'm going to put an open circle. So that's telling me things start at 9, but it's everything less. Now what's less than negative 9? Well, it's all the stuff over here to the left. So my answer needs to go like this. So anything over here, if I plugged it back in here, should make this true. Let's pick something. Let's pick negative 10. Because isn't negative 10 less than negative 9? Okay, so let me check that. Negative 4 times negative 10. I'm just picking it because it's less than negative 9. Plus 6. Is that greater than 42? I'm asking. I'm not saying, I'm checking. So negative 4 times negative 10 is 40. Plus 6, is that greater than 42? Well, it looks like it because 40 plus 6 is 46. And 46 is greater than 42. So lo and behold, it checks. So when you multiply or divide by a negative, let's highlight that. So here I divided by a negative when I needed to solve it. And when I did that, I had to flip my inequality. Oh, happy day. It worked out. Let's try one more. Here's negative 3 times the quantity x minus 9 is greater than or equal to 15. Now, what I want to realize here is I have two factors. This is a factor, negative 3, and so is all of this x minus 9. That's a factor. So I can almost think of this problem like this. Negative 3x is greater than 15. Here's my two factors, negative 3 and this other term x. So I only write this to help you see that just as these are two factors, negative 3 and x, these are two factors, negative 3 and everything inside this parenthesis. Well, if this is true, and it is, what I want to do is I want to undo this multiplying, because negative 3 is being multiplied. I'm multiplying times all this. So what undoes multiplying by negative 3? Well, dividing by negative 3. So I'm going to divide both sides by negative 3. If I divide this side by negative 3, I'm going to have to divide this side by negative 3. Well, conveniently, oh happy day, these will cancel. And all I'm left with is this term here, or this factor, excuse me, I should say factor. That is x minus 9. But because I divided by a negative, I've got to flip. I'm going to flip the inequality. 15 divided by -3 is -5. Now I have a one-step equation left to solve. I'm subtracting 9 from x. So to undo subtracting 9, I'm going to add 9 to both sides. When I do that, adding something to both sides of an inequality does not change it. These will cancel out, and I'm left with x is less than or equal to 4. I have a positive 9 and a -5. That's going to be equal to 4. So if I have $9, I spend 5, I have 4 left over. So let's graph this and let's check it. So here's 0, 1, 2, 3, 4, 5. So here's 4. What I'm saying, if this is true, that x can equal 4, because of the line there, less than or equal to, and it's everything less than 4. So what's less than 4? Well, all this junk over here, right? So all of this should make everything over here in this part of the number line, if I put it in here, should make it true. Let's pick it. Let's do something easy, like 0. So if I plug in 0 back into the original equation, instead of x, I'm going to put in 0. I just picked 0 because it's over here. Minus 9. Is that going to be greater than or equal to 15? Well, order of operations, say I do everything in the parentheses first. 0 minus 9 becomes -3 times -9. Is that greater than or equal to 15? Well, negative times a negative is a positive, and 3 times 9 is 27. And lo and behold, 27 is greater than or equal to 15. So it checks. Oh, happy day. Hope this helps. Go have yourself, concentrate. Go have yourself a refreshment.